All right, guys, today we are going to be talking about quadratic regression. And as we talk about quadratic regression, all that really means is that this is going to be a statistical method used to fit a quadratic model to a given data set. And so, guys, basically what that means is that if we are given some data that does not line up exactly, but lines up pretty close to something that would look like a parabola or quadratic function, we want to find the line that best would fit that data. We want to find the formula for the line that would best fit this. So this is a method that we will use to do that. So for number one, it says a projectile is launched into the air from the ground. And this table shows the height of the projectile, ht, at different times, but based these different times. So based on this table, we want to find a quadratic equation that best fits this data. Okay, so we will do this with a calculator, okay? We are going to input our data into a calculator. So you are going to want either a TI-84 Plus, or you can follow some steps from question number 2 for how to use it with Desmos.com. But basically, guys, what we're going to do is we're going to put all of their x values into list 1, and then we're going to put all of our y values into list 2. So I'm going to go ahead and get started and show you guys how to do that. So you have your TI-84 Plus here, and what you're going to do is you're going to hit stat. Stat is right underneath your delete button and 2 over from your alpha button, kind of right next to all those arrows. So when you hit stat, then we're going to edit, because we're going to edit our lists. All right, and then the first thing we're going to do is we're going to enter all of our x values into list 1. So I'm going to go here and I'm going to say, all right, that's 5, 10, 15, 20, 25, 30, and 35. So we have all of our x values right there in list 1. Then I'm going to scroll over and I'm going to hit enter, step 4, all of my y values into list 2. So I'm going to go here and I'm going to do 1353, 2460, 2460, 3323, 3940, 4313. Oh, you did that wrong. 4313. You want to make sure you get them exactly right. 4440, 4323. So I'm going to go back and double check these y values. 1353, 2460, 3323, 3940, 4313, 4440, 4323. So I have all of my y values and all of my x values. So now what we're going to do is we're going to go back and we're going to hit stat again. But instead of edit this time, we want to scroll over to calculate, because now we want to calculate something. And we're going to calculate the quadratic regression. So you can either hit the number 5 or scroll down to number 5. We want to do quadratic regression. We're going to hit enter, and then we hit enter 5 times. So we're confirming the list 1, the list 2, and this other stuff. And then as soon as we get down to calculate, it's blinking. You hit that, and you get the A value, the B value, and the C value. The calculator just gives it to you for the quadratic standard form. So once you have this information, you go ahead and list it out to the nearest hundredth, and then you're going to write your equation in the standard form. So I'm going to go over here and I'm going to write out my values. So I have my A value is equal to negative 4.899. So if I round it up, that becomes 90. My B value is 294.96. Yep, because of the rounding. And then my C value would be 0.57 would be my C value. So now I would go over here and I would say, all right, well, my standard form equation is y equals a x squared, there's my pan, and then plus b x, and then plus c, whatever my c value is. So if I was going to rewrite this equation, it would look like, let's see here, it would be y equals, and then my a is negative 4.90. And then it's an x squared. And then plus b is plus 294.96, and that's with our x, and then plus our c value, which is 0.57. So my final equation would be negative 4.90 x squared plus 294.96x plus 0.057. So that gives us our a value, our b value, and our c value. You cannot forget your x squareds and your x's when you're doing this, okay? So this is how you would do it on the calculator. And if we scroll down and look at number 2, you would do this one the exact same way, following this set of steps right here on your notes. Or, but the difference is we have our size and our cost. Here we're making flying discs to use as promotional materials. And the table shows the cost of 100 flying discs based on the desired size. So our size would be our x, and our cost would be our y. So that means you would put your list 1 values right here, or your list 2 values in for your y. All right, so if you wanted to follow the exact same steps, you could get your a, your b, and your c. I'm also going to show you guys how to do this on Desmos in case you don't have a calculator. So what you're going to do is you're going to pull up this Desmos Desmos.com/testing/Texas/graphing. I'll put the link in the bottom of our page here. But what you're going to do is you're going to go here and you are going to add. You click that little plus sign and you click add a table. And in your table, in your x1, you're going to put all of your x's. So we're going to do 4, 5, 5.5, 6, 6.5, and 7. I think that's it. 1, 2, 3, 4, 5, 6, 7. Okay, 1, 2, 3, 4, 5, 6. I'm missing one. Oh, 4.5. There we go. So that's 4.5C and 5. So thankfully it added one in there for us, which is good. So we got 4, 4.5 all the way down. And then I'm going to put my other values here. So that's 34.99, and that is 44.45. And I go to my next y, which is 54.95, 66.50, 78.95, and 92.45, and 106.99. So it's really important that you take a look at these and you double check and make sure that these are correct, because otherwise your data will be wrong. So the devil is in the details here. So you want to make sure you get all of these guys right. Now, once you have this, what we are going to do is we are going to actually add an expression now. And I'm going to move this to the top. And our expression is going to be our standard form equation. But on Desmos, it's going to look a little bit different. So how that looks is we will go here and we will say y, and then instead of equals, we're going to do this little tilde, this little like squiggly line, all right? And so we're going to say y equals, and that is found above your tab button. You have to hit shift. It's above your tab button next to your 1 button, so you have to hit shift to find that little button. And we're actually going to say, instead of just y, we're going to say y sub 1, because we want to do everything that's in this y sub 1 graph. So we're going to say y sub 1, and then tilde is equal to, and then we can say a x sub 1, and all you have to do is you just have to type in the letter 1, and it pops it down. But then we want to square it, x sub 1 squared, plus b x sub 1. So we say plus b x sub 1, and then just plus c. And when you do that, it gives you your data right here. So it gives you your A, your B, and your C. So if you type in that little tilde means it's regressed. So we're saying that y, or x, is regressed against y. And so when we do that, we'll actually be able to see our data. And guys, you see the points are all, actually, some of them are actually plotted right here, which is really neat. And so, and we'll actually zoom out and we can see the whole quadratic, the functions that actually got plotted. So we'll look here and we see that our a value, according to our, oh no, what just happened? There we go. Our a value, according to Delta Math here, is 2.01. Our b value is, oh, not Delta Math, Desmos. Our b value is 1.895. So that's going to round up to 1.90. And then our c value is negative 4.75. All right, so our c value is at negative 4.75. So now that we have those, we can go ahead and type in, we can go ahead and write our whole equation. So it's going to be y equals, and then it's going to be 2.01x squared plus 1.90x, and then minus 4.75. So this would be our final equation that we would be interested in getting right here. And so what we see when we get these things, and guys, actually, if we want to change our stuff so we can actually see these guys here, I'm going to go from 0 to 10, that's great. But my x-axis, I'm going to go from, let's see here, negative 5 to, I want to go all the way up to, I don't know, 150, so that I can see all of this data. So if I went ahead and I just clicked this little settings and I changed my y range. And guys, look at that. You can actually see all these points that we plotted are actually on this graph right here. So these are two different ways that you can do quadratic regression. You can use your calculator or you can use Desmos.com. All right, now we are going to move on to quadratic applications. Okay, so let's take a look. Quadratic applications. This is great because with quadratic applications, this is something that is very much used in real life. And a lot of times they do things like with the path of things. And so this drawing is a great representation of objects that are in vertical motion that are affected by gravity. So I'm going to go ahead and get rid of this. And there we go. So that are affected by gravity. And so you can see oftentimes with our, this is the shape of a parabola. And we can go up and then we can go down. The height is often going to be our y value right here, okay? And so for each word problem, we want to answer the questions using we want to answer the questions that follow. So the path of a ball that is kicked upwards can be described with this equation. So that's h equals 35t minus 5t squared, where h is the height of the ball in meters and t is the time in seconds. So h is going to be our y and t is going to be our x. So we want to know how high is the ball after 3 seconds. So this is going to be our t right here. So what we do is we go ahead and we write our equation. H equals 35, and then instead of t right there, we're going to put in our 3, and then minus 5, and then instead of t right there, we're going to say 3 squared. All right? And so what we can do is we can just put that right into our calculator, and we can say, so this is after 3 seconds. So we're going to say, all right, we'll turn it on, clear that out from our regression, and I'm going to say 35, 3 times 3 minus 5, 3 squared, and that is going to give us the height of 60 meters. All right, so that's going to give us an h that is equal to 60. Also, we could have said, okay, 35 times 3 is 105. 105 minus 5 times 9, that's 45. It would have given us 60. And so after 3 seconds, our height was 60 meters tall. Okay, and so also another thing that you could have done in this situation is you could have typed in your equation into your y equals, and you could have said 35x minus 5x squared. And then if we went to our second table here, we could have scrolled down to 3, and we would have found that it is right there at 60 meters, okay? And so what's neat about this is this shows that our little football here is going to start in a certain spot, and it's going to go up, 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 and down. And so after about, let's see here, this is a very rough graph. Let's see. That's my x and my y. After about, let's see here, 1, 2, 3, 4, 5, I think it lands back down at 7. Okay, so 1, 2, 3, 4, 5, 6, 7. Okay, so this is not a great graph, but what we can see is that at 3 seconds, my ball would be about there, which is about 60 meters. And one thing I want you to notice is that the ball reaches that height again. Do you see that on the parabola, it's going to hit it another time? And so if you look on your table, you can see that my ball reaches the height of 60 meters at 3 seconds on its way up, but then look at that. It hits it at 4 seconds on the way down. So that's important to notice that it hits it in both places. Okay, now B is asking at what time does the ball reach the maximum height? All right, so when it says, what is that height? So we want to know, what is our maximum height? Well, guys, our maximum height will be reached at our vertex, okay? So that's very important. Your maximum height gets reached at your vertex. Well, how do we find our vertex when we're in standard form? We are going to use that axis of symmetry. So we're going to say x is equal to negative b over 2a. So my x value would be equal to negative b. Well, remember, the b is the coefficient to our x term. So that would be negative 35, okay? And then times 2 times a. Well, a is the coefficient to our x squared term, or in this case, our t squared. So that'd be 2 times negative 5. So that's going to be negative 35 over 2 times negative 5 would be negative 10. So that would reduce down to 3.5t. So that, or t is equal to 3.5. There we go. So, so it is at, that's, I guess, seconds there. So at what time does the ball reach the maximum height? It's 3.5 seconds. So now we want to figure out, well, what's the value of what is the height at 3.5 seconds? So what we're going to do is we're going to take that 3.5 and we're going to plug it into our equation. So we say h is equal to, well, our original equation was 35t. Well, my new t is 3.5 minus 5, and then times t squared, so that's 3.5 squared, okay? And then what we need to do is we're going to plug that in, and we're going to see what happens. So we go here, second quit, and we have 35 times 3.5 minus 5 times 3.5 squared. Now it's important to keep those parentheses in there. And when we do that, we see that it's 61.25. So my h is equal to 61.25. And remember, that's going to be in our meters because our height was measured in meters. So what we can say very confidently is that the ball reaches a maximum height of 61.25 meters at 3.5 seconds. So that is the way that we can give this answer. The ball reaches the maximum height of 61.25 meters at 3.5 seconds. All right. Now, let's take a look at number 2. This is also another object in motion. So an archer shoots an arrow into the air. The equation that describes this path of an arrow is h equals 17t minus 5t squared. Okay? Where h is the height in meters and t is the time in seconds. So guys, if we were going to rewrite this so it actually looked like it was in standard form, the way that I would write that is I would say h is equal to negative 5t squared plus 17t. Okay? So that would help us see that that this would be our a value right here, and that would be our b value. Up here, on this first one, I didn't rewrite it because that 35 was our b value, and that negative 5 was our a value. So if we wanted to rewrite it like that, we could. We can solve it in both ways. All right? And so we want to see how high is the arrow after 2 seconds. So I want to know how high is that arrow after 2 seconds. So what we do is we say h is equal to 17, and instead of t right there, we're going to put in 2, right? Because the 2 seconds. 17 times 2 minus 5, and then we're going to say 2 and squared, right? So we want to know what is our height going to be. So let's pop it in the calculator and let's see. So we have 17 parentheses 2, so that's 34 minus 5 times 2 squared. So that's going to be minus 5 times 4. So I think it's going to be 14, right? 34 minus 20, yeah. 14 meters. So what we see here is that our height is going to be 14 meters, okay? Now remember, you can also do this by plugging it in here, and you get, okay, 17, I'm going to clear the whole thing out, 17x instead of t, 17x minus 5x squared, and then you hit second table, and it does the work for you. And you see right there that it equals 14 meters, all right? And I really like this problem because I think it's good for us to see what it equals in different things here. So that equals 14 meters right there. And then what we're going to do is we want to know what time does the arrow reach the maximum height. Well, remember, our maximum height is going to be our vertex, right? So we are looking for our vertex, and we want to know what is that height. So we have to find our x value, and then we have to plug in the x value to find our y value. So what we're going to do is we're going to say x is equal to negative b over 2a. Well, let's take a look at what that is. My negative b, my b is 17, right? Because it's the coefficient of my t variable or my x variable. So that's negative 17 over 2 times a. My a value was negative 5. Again, that's cool. So that becomes negative 17 over negative 10. So that means that my t value in this case would be positive 1.7, and that would be 1.7 seconds. And remember, this is our t. All right, so my t is 1.7. So now what we're going to do is we're going to take this 1.7 and we're going to plug it back into our original equation to see what our h value or what our y value is. So in this case, I would say h is equal to, and I'm going to just plug it into my original equation, this 17, and then instead of times t, I'm going to be doing times 1.7 minus, and that's minus 5 times 1.7 squared. All right, so we have minus 5 times 1.7 squared. Sorry about the colors being a little off there. So then we go ahead and we just use our calculator here. We're going to plug that in. We're going to say y equals, and I'm a second quit. So I'm going to say, all right, 17 times 1.7 minus 5 times 1.7 squared. And when we plug that in, we see that that is equal to 14.45. So my height is 14.45 meters at the vertex. So that means my vertex is, so yeah, I guess we didn't really write this up there, but my vertex is 1.7 and 14.45. So how we would write that is we would say the arrow reaches its maximum height of 14.45 meters at 1.7 seconds. So this is how we would write our final answer here. Okay? And remember that x was our t and the height was our y. All right, so I hope that that helped you guys out today to have a little bit of regression and application, and good luck on your test next week.